Hello everyone, good morning, good afternoon and good evening. My name is Vishwadeep and I welcome you all on PW Gatewala channel. Today we are going to discuss three different algorithms. Yes, yesterday we have seen SRTF, through which a lot of questions have been asked in GATE in past. Today we are going to discuss three algorithms, LJF and LRTF, which are just the opposite of SJF and SRTF, and then priority based algorithm. So let's start the session. But before we start, I want your presence over here and I want everybody present over here to comment. Are you guys ready for the day? Yes or no? Just let me know. Okay, so first we will start LJF. Till the date, there is no any gate question from this particular topic, but still we should we should practice it for just one question at least, so that we can understand how exactly the opposite algorithm will work. So longest job first says that the biggest process which is having the biggest burst time should be scheduled first. Simple. So scheduling criteria is largest burst time process first. But sir, if two processes are having equal burst time, then what should be the tiebreaker? Can you type down in the comment box? In SJF, what we use as tiebreaker? FCFS. So here also FCFS. This SJF, shortest job first, is non-preemptive. This is also non-preemptive. Yes. Okay. Let us solve a question quickly so that we can understand how does this particular algorithm works. So this first question, okay, if this question we will have to solve, look at this. I will just draw the Gantt chart and I will leave the rest of the things over you. Why? Just because you also need a practice now. It might possible that during the live class you are not able to. Later on you can, but just do practice. Finish these and have the average waiting time, turnaround time calculated. Reason: if you will practice, you will be having quickness, the speed you will achieve, accuracy you will achieve, and that will help in the gate examination. That known type of easy questions you can solve quickly in the gate examination. Okay, so first process, look at this. What all processes arrived at time 0? All processes arrived at time 0. So if all processes arrived at time 0, then among them which process I'll have to schedule? The process which has largest burst time, which is P1. So P1 I will schedule first. After that I will schedule P3 plus 4. Then next large process P2 plus 3, and next large process P4 plus 2, 15, and done. This is the way processes are executed. Simple. Total 15 time duration. Here we are having 15. No any difficulty to understand this? Can you please let me know if you guys are understanding this one or not? Just let me know quickly. If yes, then we will solve another question. I hope you guys will give a try. I am giving you 1 minute of time just because it's a non-preemptive algorithm. In 1 minute, just get the Gantt chart prepared. Just the Gantt chart get prepared for this one. Quickly. I am waiting for you guys. Quickly do it. Quickly. Yes. Good. Can you solve it? 1 minute. Not more than that, boss. Only 1 minute. Okay, good evening. Look at this. I guess this is enough. If you have already practiced SJF, then LJF will not be a trouble for you. Look at this. Processes are not arriving all of them at 0 time. At 0 time, we were having only one process P1. So we will have to execute P1 only. We will have to schedule P1 only. LJF, non-preemptive. If P1 is given for execution, it will complete. So it will complete till 2. Complete, yes, till 2. What all processes, other processes arrived, arrival time I will check. Process P2 and P3 arrived. Now among these two only, which one is largest? Longest job first is the algorithm. That is primary job. Our primary job to choose the biggest process. Biggest process is P3. Let's run P3. 4 time unit till 6. After that till 6, this also arrived. This is also remaining. Which one is the smallest one? Largest one, P2 till 9. And after that, P4 till 11. And this is how your Gantt chart looks like. Shivani, you have made a mistake. Okay, you are choosing this largest process, but at time 0, P3 did not arrive at time 0. How can you schedule P3 which will arrive at 2 and you are scheduling at 0 only? This is same as you are already reaching to IIT Bombay's campus and saying that, okay, give me the admission. The people will ask, where is the gate score? It will come in future, but give me admission just because it will come good. They'll say, come when the result comes. Schedule the process when actually it is available. Look at this. Further, LRTF. LRTF says that the LJF is non-preemptive algorithm and its preemptive version is longest remaining time first. Longest remaining time first. It is exactly like SRTF and SJF, LRTF and LJF. So scheduling criteria is same. Longest burst time process first. Here also the tiebreaker is same, which is what? Which is FCFS. True, yes, but the type of algorithm here is preemptive. The algorithm type is preemptive this time. Now, SRTF and LRTF are not little, way too different than each other in terms of their execution. I will explain. Through an example. Look at this. This is an example. 4 processes, 0, 1, 2, 3. Their arrival times are, execution times are 2, 3, 4, 2. Now, let us try to execute them one by one. I will need your full attention over here. Everybody, present or not, raise your hand actually and tell me, yes, you are present. Even if you are not able to type, at least loud and clear, say, sir, I am present, and focus here just because this is little different. And if somebody comes later and says, sir, can you please repeat again? No, I will not. Just because of your concentration problem, I will not. So be here. I'm telling you once again, be here at time 0. I will go slow, but everybody should be here for entire explanation. At time 0, which process is available? It's okay if you are not commenting. If you are commenting, that will be best. At time 0, which process available? At time 0, only P1 arrived. Later, these 3 will arrive later. So let's go ahead. Let us go ahead. Let us go ahead means what? P1 will run with 1 duration time. Why? Just because at 1 another process P2 arrives. So I have executed P1 1 time unit. Fine. Now what happens if I have executed P1 already for 1 time unit? Remaining time is 1. Remaining time is 1. Now if remaining time is 1, at 1 time P2 arrives, P2 is having burst time 3, P1 is having remaining burst time 1. Between these two, which process has longest remaining time? Longest remaining time is with P2, so P2 will run. P2 will run. Yes. P2 will run. Yes. Now P2 will run means P1 preempted and P2 will be executed. I will execute P2 for another one time unit. Remaining time I have updated. Now remaining is only 2. Now at time 2, P3 arrived and P3 arrived with even larger burst time 4. So I will have to preempt P2 and P3 will be scheduled. P3 will run. P3 will run till 3 time unit. Its remaining time is 3 and then I will see P4 arrives at 3. When P4 arrives, its burst time is 2, which is lesser than current running process P3. So P3 is having higher burst time. Remaining burst time more? Yes. So we will continue with P3. Okay, let's continue with P3. I will continue with P3 till what? Till final execution? No. This is where this algorithm is little different than SRTF. Look at this. Look at this. All processes arrived, yes, but in LJF it does not happen that when a new arriving process occurs or comes or arrives, then only preemption happens. In SRTF, when a new arriving process is there, and that process is having smaller burst time than the current running process remaining time, then preemption happens. If no any process arriving later, no preemption. Simple. But here, even if after 4 there is no any process arriving, still there can be preemption. How? Look at this. P3 I have run for 2 duration of time. Its remaining time is 2. And look at this. Time is reducing, boss. Time is reducing. If time is reducing, then what happens? All 3 processes are having equal burst time. Now P3's burst time is equal to P2's burst time also and P4's burst time also. So if that is the case, we will have to go for tiebreaker, FCFS, and FCFS which comes first? P3 comes first? No sir, P2 comes first. So I will run P2. But as soon as you run P2 for one time duration, its remaining time is 1. And look at boss, P2 is no more the longest one. We have largest process P3 and P4 just because P2's remaining time is just 1. Then what we should do? We should prioritize P3 and P4 just because they are having larger burst time. Now what? If larger burst time, then we need to schedule the process which arrives first. P3 arrives first, so we will schedule P3 for one duration time till 6, remaining time is 1. Now as soon as you are running P3 for one time duration, look at this, P1, P2, P3 all 1, 1, 1, but P4 is 2. Oh wow, so I'll have to schedule P4. P4 also runs for one time duration till 7, remaining is 1, and now all processes are having equal burst times. If all processes are having equal burst time, then I will have to schedule as per the arrival time. P1 arrives first, so P1 will schedule first, will run for one time and complete. Then P2 arrives next till 9, finish. P3 arrives next till 10, finish. P4 arrives next till 11 and finish. This is how LRTF will work. This is how LRTF will work. So you need to reduce the timing one by one so that the processes can be running always the largest process. And this is how it goes. Just check once. If at all you guys are not able to understand, let me know. Everything clear? If yes, Remaining things you can do by yourself as a practice. Why I am telling you guys? Just because this is the main difference between a normal thinking process person and a topper's thinking process. Average person's thinking process is what? I know how to do that, I can anyway do that. But the topper will practice it more and more, so that even though topper knows how to do that, topper will be cracking the speed in that. Now average person knows the method but will solve such kind of easy question in 5 minutes in gate examination. Topper will solve only in 2.5 minutes. Topper will save 2.5 minutes for other questions which are difficult and lengthy, and hence topper will get more marks eventually, just because he will be able to attempt more number of questions. Average person, even though person knows a lot of things, he will not be able to get the time, and that's why I'm saying practice and practice and practice and practice more and more and more. Okay, now this question is having a small catch, a trick. What is the trick? If they are not asking, if they are not asking how many context switches are there, they are just asking completion time or turnaround time or waiting time. What you can do, total how much time processes will take. 4 plus 3 7 plus 2 9 plus 2 11, total 11 time needed. So last process will be completing at 11 here. Which one? As per the arrival time sequence, P4. Just before that, P3 will complete one time ago. P2 will complete, which is arriving before P3 at 9, and P1 will complete at 8. P1 completes at 8, P2 at 9, P3 at 10, P4 at 11. Why 1, 2, 3, 4? Just because in their arrival time sequence. So what you can do is, without drawing the Gantt chart, if you want only completion time, based on that maybe turnaround time or only waiting time, then what you can do is just draw this much. But this particular thing will work only in the cases when all the processes will be finishing at the end. It should not happen that one process can complete before other processes are arriving. If a process is completing before other processes are arriving, then the problem can occur. Then in that case, this one will not work. In this current case, in our case, all 4 processes will go till the end, just because no any process is completing. P1 will run one time, and before it completes, P2 arrives. P2 will run one time, and before that, P3 arrives. P3 will run one time, and P4 arrives. So somehow there is no any completion of any process before other processes are arriving. This particular trick can work directly, and that you can put over this particular question and get me the answer quickly. You won't have to work hard for this particular question, just because trick I have explained you, and you can just do that particular trick. Trying? This will be so easy for you. Okay, let's try to understand what I told. All processes, process ID 0, 1, 2 with compute time burst 2, 4 and 8, 2 plus 4, 6 plus 8, 14 total. All processes arrive at time 0. So if all processes are arriving together, no any process will complete before other arrives. So in that case, LRTF algorithm will execute, last process will run till 14, before that 13 and before that 12. P0, P1, P2. In that sense, these processes will complete. So completion time of P0, P1 and P2 will be 12, 13 and 14. Turnaround time will be completion time minus arrival time. Arrival time is 0 only. Average turnaround time will be equal to 13. 12 plus 13 plus 14 divided by 3 is 13. Calculation is so easy. Option A is correct, and it is a gate PYQ which we solved now. Superb. And what is there? Just a trick. We don't have to solve entire Gantt chart. Why? Because we got to know a small trick. We have used it, solved the question in some lesser time. Other fellows who know the method but do not know the trick will not be able to solve it quickly. That's why I was saying, when you keep practicing questions, you can by yourself get such kind of a trick, small tricks which you can eventually invent by yourself, and then you will be saving a lot of time with that practice in the examination. The next thing is priority based algorithm. See, LRTF, LJF, only one question which we solved just now. Till date in the history, there is only one question. So this is enough. We don't have a lot of practice questions and test questions on that, but knowledge is enough for you guys till this level. Priority based algorithm, there are few questions, so we will solve them. Let's go ahead with that. Scheduling criteria, just because it is priority based algorithm, name suggests we will have priority for each process given in the question and we will follow that. Higher priority process first. Higher priority process first. Whichever process is having higher priority will be scheduled first. But sir, what if two processes are having equal priority? See, two things. First, till date in the gate history, entire gate history, there is no any question where two processes are given with equal priority. Not at all. But if in case in future they will give a question in which two processes will have equal priority, then they will mention in the question that what is the tiebreaker. If two processes are having equal priority, then they schedule the process with a smaller burst time or smaller arrival time or whatever. They will always mention. So what if it will not be mentioned? Don't worry. It is a gate question. It is a standard question. It is not like a test series question. In the test series, people will give the question in such a way, they will assume that whatever I taught is a standard. So it may happen that teachers or the students who are creating the questions, yes, sometimes students are also creating some questions for some test series. So if they are creating some questions, they may give such kind of thing without giving that what is the tiebreaker, but tiebreaker should be given in gate question. So do not worry about it. In the gate examination, tiebreaker will be given, even though tiebreaker will not be given, will not be needed, just because two processes will not have equal priority given in question. What is the type of this algorithm? Type of this algorithm is preemptive and non-preemptive both, which means preemptive version is also available, non-preemptive version also available. That will also be mentioned in the question, that which version should be used for solving this specific question. So you need to read the question very carefully, that we will have to solve priority based algorithm preemptive version or non-preemptive version. It will always be mentioned in the question. Always, yes, always. Okay. Sometimes they have asked questions in which they asked, this is the process scenario, solve it with priority based algorithm and preemptive, non-preemptive both, get the result and match the option. In priority, non-preemptive, priority, preemptive, what will be the average waiting time or something. So in the option they will give both the options, both the things, that with preemptive average waiting time is this, with non-preemptive average waiting time is this, like this they may give the options. So always they will give you the preemptive versus non-preemptive. Now next question. If process P1 is having priority number 6, P2 is having priority number 3, which is higher priority process? Which is higher priority process? P1 is having higher priority or P2 is having higher priority? Bigger number we will consider as higher priority or a smaller number we will consider as higher priority? That is also there is no any standard about. No any standard. It can be. It can be. Huh? See, it is purely implementation based thing, Babu. Sir, you are giving lot of information. See, every information I am not giving, it will be given in the question directly, indirectly, somehow. That higher number I will consider, or bigger number I will consider as bigger priority, or smaller number I will consider as higher priority. Always, yes, always. So please read the question carefully. Do not assume anything. Just because I have seen students solving by their own assumption. Sir, I have to solve this question for higher number, higher priority. I did not even read the question. If you don't read the question, you don't get correct answers. You won't get good marks. Then IIT people don't read your name. So what exactly I am saying is simple. Properly you need to read the question before you start solving. Read the question 2 times, 3 times, understand it properly, then only you start. Question itself will say, Malik, this is my answer. You just understand and get this answer. That's it. When you will read the question and understand properly. So, higher, larger number considered as higher priority or smaller number that will be given in question. That will be given in question. Like this, look at this. This is a process scenario given. 5 processes are there. Their separate arrival times are given. Their burst times are given. And priority number is given. This will be given in the question if they are asking about priority based algorithm. And look at this. If you will, observe this in the question, indirectly given that 10 is highest priority. Now you can compare easily. 10 is highest priority. Among all these numbers, 10 is the largest number. Largest number having higher priority, which means a smaller number of priority is a smaller priority. So 4 is lesser than 5. So 5 is having higher priority than 4. Simple. Okay, let's solve it for non-preemptive version. And we will solve the same question for preemptive version also. Don't worry. We have, yes, same to same we have. So first of all, non-preemptive version, if we are solving, at time 0, what all processes arrived? Tell me, which process arrived? Only one process, P1 arrived. Only one process, P1 arrived. If P1 arrived, P1 will run. For how much duration? It will completely execute just because it's a non-preemptive algorithm. Now look at this. For this P1 process, priority number is 4. Burst time is also 4. We will run it for burst time execution 4. P1 completed? Yes. Till time unit 4, when P1 was executing, these all processes arrived already. At 1, P2 arrived, 2, P3 arrived, 3, P4 arrived, 5, P4 arrived. Sorry, at 4, P5 arrived. All processes arrived? Yes. Among these processes, which is having highest priority? Among these 4, highest priority is P4. Okay, P4. Executed? Yes. For how much duration? 1. Remember, this is one of the biggest mistakes student does here is check the priority and they take that priority number as burst time. They run P4 for 10 duration of time. Please do not make this mistake. While practicing, you just try to understand this. We will have to run P4 for only 1 duration time till 5. Now next highest priority process is P5. We will run P5 for 2 duration of time till 7. Then next highest priority process 6 priority P3 runs for 3 duration time till 10. At the end 5 priority P2 will run for 2 duration of time 12. At the end you can check burst times so that you can cross check 6, 9, 10 and 12. Summation of all the burst times 12. Yes, 12. This is how you can solve. Okay, the same question if I am solving with preemptive version, what happens? What happens? Look at this. If I am solving the same with preemptive version, at time 0, we have only one process arrived. Look at this. Only one process arrived, P1. If P1 runs, for how much duration it will run? Either it will complete or it will run till next process arrives. In priority based algorithm also, we will have to run P1 till next process arrives. When the next process arrives? At 1. At 1, P2 arrives. So I am running it for 1 duration time. Its remaining burst time is 3. Then at 1 time unit, P2 arrives. And when we check, compare the priority 4 current running process is having, 5 the next upcoming process is having. Aha, upcoming process is having priority more. In this question, higher number, higher priority. So process P2 which has arrived having higher priority, small priority process removed. P2 say, hey P1, go out. I will run now. I have higher priority. So scheduler will preempt P1 and will run P2 next. But P2 also runs only 1 duration time just because at 2 another process P3 is arriving. So it runs for 1 time, remaining is 1, and at time 2 P3 arrives which has priority 6. Current running process priority 5 and P3 arrives with priority 6. Oh, P3 is having higher priority. If P3 is having higher priority, let's run P3. P3 will run till 3. Remaining time 2. And at 3 P4 arrives. P4 arrives. P4 says everyone is gangster until the real gangster arrives. The real gangster is highest priority process P4. It will be now scheduled and P4 runs for 1 time till 4 and completed. Now at 4, another process arrived which is P5 and P5 is having higher priority than remaining all other processes which are waiting. So P5 will be scheduled till what time? Till 6. Why you are running sir till 6? Just because I can understand there is no any later arriving process now. If there is no any process coming later, then this will remain highest priority processes among remaining. Simple. So P4, P5 will complete. Then now based on the priority, I'll have to schedule P3 first. Remaining time 2 till 8. Then P 2 next plus 1 9 and then P1 at the end till 12 plus 3. Remember again, I am reminding you guys again. Do you listen that? Are you listening this? This burst time I'll have to execute the processes for. This is just for the scheduling that which one should be scheduled when. But I'll have to execute processes for the burst times. Do not consider this as burst time. Okay or not okay? Okay or not okay? Okay or not okay? If yes, then can you solve this particular priority based question non-preemptive? Please consider every value given and how the priority given and solve it. I will give you exactly 2 minutes. Exactly 2 minutes. Try and solve this. I just want the Gantt chart. If you get the Gantt chart properly, then the rest of the things are same to same for every particular question. Okay. Let us solve this question for you guys. Let me solve. Non-preemptive version is very simple. At time 0, if you see only P1 arrives, I'll have to execute only P1. And P1 will execute completely. Completely means burst time 7. Done. I did not even check the priority, boss. Why? Just because there is no any other process arrived. Only one process. No option. Execute that process only. Further, next what? If this P1 process completed till 7, all other arrived. When all other arrived, I'll have to check which process has highest priority. This time opposite given. Smallest number having higher priority 1. So process P4 highest priority process will run next. Process P4 will execute only till 2 time, till 9. Then next process which is having next priority 2, P3. Till 5 it will run. I have run it till 14. Done. Next priority is 3. P5 will run till 6 duration time 20. Then next priority 4 which is P2, it will run for 3 23 and at the end 8 priority P6 till 1 duration it will run and done, which is till 24. Again I will cross check if all processes are running till 24, 10 and 13, 23 plus 1, 24. Yes, it is correct. Is this the Gantt chart? You got it? You got the same Gantt chart? If yes, I am quite happy with you guys. If yes, let's go with this one then. Priority based algorithm. Same option, same question. This time you need to solve it with preemptive. Preemptive. Preemptive algorithm. Same question. Try to solve now with preemption. A lot of preemptions will happen in gate questions. In gate questions, usually maximum 4 or 5 processes are given. I am giving you more 6 or 7 processes because we want practice. That's it. If we have practice of more processes questions, then you can solve easily lesser processes questions. Done. Done, 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 done. Okay. Done, done. London karo ji. At time 0, Gantt chart starts. Only one process arrived, sir. Remaining all arriving later. So we will start with P1, but we will run P1 till only next process arrives, and we will see if P1 continues or preemption happens. So we will run P1 till next process arrives at 1 till 1. Remaining time is 6. Now at 1, P2 arrives, which is having lower number priority, which is higher priority. Smaller number highest, so 4 is lesser than 9. 4 has higher priority than 9. P1 will be preempted, P2 scheduled. P2 scheduled, P2 will again run till only when next process arrives. At 2, next process is arriving, P3. So till 2, P2 runs. Next, if P2 runs till 2, one time during, one time unit, okay, remaining time 2. The changing in remaining time is very important in preemptive algorithms. Very important. You can write down in separate column, separate list, so that you won't make any mistake. Please write down all the time. Now P2 I have preempted. Why? Just because at 2 P3 arrives, which is having higher priority than P2. Higher priority, lower number priority is higher priority. So P2 preempted, P3 runs. P3 runs till 3. Now at 3, another process P4 arrives. Remaining time I have changed. P4 arrives at 3. P4 is having highest priority. P4 should be given highest priority. P4 runs. if P4 runs, I will run it till 5. This is the trick. I have practiced and I have learnt. Sir, highest priority P4 we have. For P4 process, highest priority we have. Then it will anyway run. Even though after that at 4 another process P5 is coming, I know that it cannot be higher priority process just because this is the highest priority process. So P4 completes at 5. Until then, these two more processes arrived. Now I don't have to have any preemption, just I will run the processes one by one. Which process? As per the priority. Highest priority is which one? 2. So P3 will run next and it will run completely till 9. Preemption will happen only when later arriving process has higher priority. Later arriving process is not there, so no any preemption there. Simple. Okay, so till 4 duration I have run P3. Next priority is 3. So P5 runs till 6. 9 plus 6, 15. The next priority is 4. P2 runs plus 2, 17. Next is 8 priority, which is P6, 1. Duration 18. At the end, 9 priority, which is highest, P1 runs for 6 duration 24. Can you please cross check if you are having the same Gantt chart or not? If yes, then we are good. If you are having same Gantt chart, then we are good here. Okay, fine. Priority based algorithm is having the best advantage is in the real time situation, best response we can get. Response of the CPU. How? Let's say I am the user. If I double click on some process, then that process is highest priority for me. Why? Just because I want my CPU to execute it as quick as possible and give its response to me that okay, process is started executing and it is working. So in the real time situation, with whichever process the user is interacting, that process should be running quickly so that it can give some kind of response that CPU is executing it. On the screen, I am getting some response that yes, something is happening in that process. So it can be done with simple thing, give the highest priority to that process which is important to the user. Disadvantages, here also we can have the starvation. Low priority processes may suffer from starvation. There is a story in IBM company, there was a low priority process which was starving for around 20 or 25 years. Yes, that's a true story. In IBM company, that is one, world's first technology company, that particular company, that one process was starving because it was very low priority process for 20 years. It was not getting the CPU at all. So it may possible that a low priority process is not getting CPU just because high priority processes are keep coming and keeping. So because of that, low priority process not getting the CPU. When it will get the CPU, no idea. When all higher priority processes will complete then. But when, no any definite time. That's why indefinite waiting, starvation. In priority based scheduling, there is a solution of this. Solution of starvation is aging. And what is that? The aging solution says that we will not keep the priority of the processes static, fixed. We will keep the process priority dynamic. It can change later. How? Operating system will observe if a process is waiting for little longer, then OS will increase the waiting process priority by 1 point. Then if it is waiting again, then another increase in the priority. Then if it is waiting again for that duration, then again priority is increasing. So aging says that you increase the priority of waiting processes by 1 after certain duration of waiting. And if process is waiting, it will be having priority increase. Eventually, this increment will make my waiting process priority as highest priority. So at one point of time, this process which is waiting will have priority highest, and because of that, it will be running and executing. No any starvation it will be stuck into. So aging is what? Increase priority of processes by 1 if they are waiting for a certain duration. All the processes which are waiting for a certain duration not getting the CPU, then increase their priority so that eventually the process will become highest priority process at a time, at some time, at some point of time. This is priority based algorithms starvation solution. Okay, that's great. So today we are done with the priority based algorithm also. Tomorrow we are going to have discussion of round robin questions. Round robin is one of the difficult and different kind of algorithm. So we will have good enough time to understand single round robin algorithm, and then that after that next class we will solve some questions based on the algorithms we have discussed, and some other type of questions where IO operation time is also included, and so on, so that we will be having comfortable execution of that particular thing also. Is this good idea to unlock Khazana and complete the syllabus thoroughly? Yes. Thoroughly means quickly. Khazana is more helpful when you want to finish the syllabus earlier than the usual time. Whenever your batch will have the live course, before that, if you want to complete, Khazana is quite a good option for that. Somebody asked about, sir, people in BTech given more priority for MTech in the placement as compared to MTech. See, companies are preferring a few specific guys for specific job roles. Some companies are preferring higher aptitude people who are having better aptitude, they will win the contest. Some companies are preferring the specialized students, like who are working in ML and AI, etc. They are preferred. So it is purely based on company to company what exactly the company is looking for. So you will have equal chance to prove your worth by your hard work. So it's very simple. You improve your understanding level and learning level, skill level, and you will be getting the chance to have a good placement. Simple. Preference. Every company has a different preference. Some company will have a criteria that you should study ML, then only I will consider you. Some companies will prefer that you should study system courses, then only we will hire you, like this. So don't worry, you will be having different lot of companies to sit into, and they will eventually give the job to you if you have some kind of skills, good skills. Okay guys, thank you so much. See you again tomorrow.